how do we look at what we have in manufacturing? And so we have many different types of data models. ISA 95 has data model, etc. So the approach that we've taken so far traditionally is, we have a database, an entity relational database, and we need to model the world into this entity relation data model, right? And that's at the core of everything that we do. All systems work that way, etc. But it's constraints because of the constraints of entity relations and kind of this translation that needs to go on. We kind of end up where we ended up. It also causes, it's not democratized. These models are very complicated, and so for people to go in and take a look at at that, they need expertise. They need somebody who understands the model and somebody who knows how to do SQL and data science and all great stuff, right? And that hinders the value of the data. One of the things with digital technology is that the premise is that you get insights into your manufacturing that is that helps you become more productive, right? Really true insights. And in order to get those insights, you cannot have data that requires you to ask somebody to go do a report for you and put it in a PowerPoint that you can look at it, or once a week, etc. You should be able to go into that data and look at it and go, I get what's going on here in this. So we need to start looking at data, from a kind of, think about knowledge graphs, etc. So knowledge graph is about how do we take our perception and perspective into data and kind of help us analyze the data, meaning like we put true relationships, not entity relationships, but relationships that make sense for us. And in order to do that, we need to also reflect on the data model. So essentially, the artifact model is just a way to structure your data in a way that is human consumable and uses human into it. Like we can do something with it, and also is ready for AI and ready for to more effective with knowledge. So how do you do that? First of all, simplify. Like we need it to be much simpler, right? So traditional data models are way too complicated. One of the things that makes them complicated is that they try to put the transactional piece of it in, right? There's things like machines and materials, but we also need to model the transactions that we do on them. How do you move them, and how do you produce them, etc. If you take that and say, okay, we don't need to do transactions that the agents do for us, right? In our world, the apps, the agents do all the activity on it, humans as well. We just need to replicate what we see on this, what do we see happening on our shop floor, and be able to do essentially a true digital twin kind of thing. So that's the premise. And actually, it is pretty simple. If you go to a manufacturing plant, okay, and again, this stems from the research we did back in the 90s. We spend a lot of time in thinking about, how do we create these true digital twins? What do you have in a manufacturing plant? We looked at many different standards and models, etc., from different perspectives. Like look at it from an operational perspective, and look at it from an operator perspective, and look at it from a design perspective, from an engineering perspective. The example is, I have my coffee cup here, right?
Yeah.
How do you model a coffee cup? If I'm let's say a process engineer that needs to make this stuff, I say, well, it's a solid that I put a hole in. I made a hole in the solid, right? Mm-hmm. If I'm a design engineer from a usability perspective, I'm thinking about, it's a container with a handle that's easy for me to catch. Like I'm looking at the handle. So everybody has a different perspective on how you model a system, right?
Yes.
And so, the perspective we're taking is a kind of a unified perspective, and say, okay, like what do you have on the shop floor? Okay, so let's start with the simple, right? And at the core, like we have machines, right? Mm-hmm. And then we have materials that have to be processed by the machines to come with a product, right? So there's a class of objects that is physical. There's a physical thing on the shop floor. We have a machine, and we have a room or a area, right? Those are called physical artifacts. We have materials, raw material, but those are, we call them physical artifacts. So those are things that I go to the shop, I can touch and feel them. I can touch and feel a machine. I can touch and feel a person. I can touch and feel a material, right? Those are called physical artifacts. So that's one thing that you have on the shop floor. So your first thing you do is classify things as either physical artifacts, and the other is operational artifacts, things that we do with. So an order, it's not something physical, but you cannot, in a shop floor, you need an order. You need to produce against a demand. That's an order. A defect is a representation, and something is a task or an event is an operational artifact. Now, if you take those two things, physical and operational, you will find that there's no more than a handful of different things in a manufacturing site, right, that can classify that. Anything else is actually, we don't think about it right now, right? So you have your machines, your tools. You think about it. Machines, tools, a room, an area. Mm-hmm. You can't come with much more than that. And then there's direct materials, raw materials, the semi-goods, sub-assemblies, final product, right? Those are the truly, that's it. And if you go to any manufacturing plant, you will typically see that they will come up with 10 different physical artifacts that they have on the shop floor. That's it. And that's manageable for humans. And that's what you need to represent in your data model.